12.1, define and use sequences and series. So, a sequence is a function whose domain, what does domain mean? Close. X values is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. Meaning that if they don't say your X value is going to be 1, the first X value you plug in would be 1. The values in the range are called the terms of the sequence. What does range represent? It's your Y value or like the answer. So your domain is what you plug in, like your term number that you're plugging in. And then the range value is the answer that you end up getting out. Okay? So domain is X, range is Y. So for instance, what they're saying is that if your first term, so it's like this is your first term, or you're going to plug it in and get an answer. Okay? For example, if you were down here, my domain is like my n value. If I were to plug in 1, so we are going to go a sub 1. We plug in 1 right here, and 1 plus 4 equals 5. So my domain is 1, and my range is 5. Okay? Confusion? This represents like your term number. Whatever term number it is, that's the value that you're plugging in for your variable. So for instance, I have 1 here, so I'm going to plug 1 here. 1 plus 4 is 5. In fact, on this, and I have to still go backwards, but you're going to do 6 terms. So I'm going to go a sub 2 would equal, and I'm going to plug 2 in for n, so we'd have 2 plus 4, which equals 6. Then I'd have a sub 3. 3 plus 4 equals 7. And you guys don't have very much room, I'm sorry. If you notice, and then I do the same thing for 4. 4 plus 4 equals 8. The 5th term, 5 plus 4 equals 9. And then my 6th term would be 6 plus 4, which equals 10. And again, you don't have very much space, but normally you would write these like in a sequence. So I would write this as 5, 6, 7, 8, 9, 10. And that's my answer. So your domain is the number that you're plugging in. Your range is your answer to once you plugged it in. Are we better with that now? So if they don't tell you, you start with 1 and then you go, in this case, it went to the 6th term. So you start with 1 and we went to the 6th term. Right, because when I plugged 1 into this formula, the formula was n plus 4. So yeah, so when I plugged 1 in, I got 5. When I plugged 2 in, 6, 3 in, 7. Okay, coming back here. A finite sequence. What does finite mean? Good. Finite means there is an ending point. So a finite sequence has a limited number of terms. An infinite sequence, infinite means what? Goes on forever, continues without stopping. Do you guys know what the infinity symbol is, right? So, basically, it's a sideways 8. Exactly. That's infinity. Okay, you know a sequence is finite. For instance, here, it goes 2, 4, 6, 8, and it stops. That is finite. Infinite, you'll notice, has a ... at the end, which means it goes on forever. Okay, so part of your homework, they just want you to write out the 6 terms of the sequence. So just like I did this on the first example, I plugged in numbers 1 through 6 and got those answers. So we're going to do the same thing here. So if I am finding my first term, we're plugging in 1 for n. I would have negative 2 to the 1 minus 1. What is negative 2? What is 1 minus 1? 0. And anything to the 0 power is? Okay, there's a lot of side conversations that are going on right now. Please don't while we're doing notes. So this was my first term. Now I'm plugging in 2. Negative 2 to the 2 minus 1, because now I'm plugging in 2 for n. Here I plugged in 1 for n. 2 minus 1 is, so negative 2 to the first power is negative 2. Okay, so then we have negative 2. Now I'm going to plug in 3. So we have 3 minus 1. So we have negative 2 to the second power, which makes 4. Next, I'm going to have negative 2 to the 4 minus 1, which will make negative 2 to the third, and that answer is negative 8. Then we'll have negative 2 to the 5 minus 1, which is negative 2 to the fourth power, and negative 2 to the fourth power is positive 16. And so I've done all the way to 5. I need one more. So negative 2 to the 6 minus 1 makes negative 2 to the fifth power, which is negative 32. And again, you should write your answer as a sequence. So we'd write that as 1, comma, negative 2, comma 4, negative 8, 16, negative 32. It'll tell you, or it'll tell you, this one gave you instructions. They wanted you to go out to 6 terms. All right, last one. This is, if you can't tell, that should have been a fraction like that. Okay, so if I'm plugging in my first term, okay, which would be a sub 1, I'm plugging in 1 for n, so I'm going to have 1 over 1 plus 1, which makes 1 over 2. Okay, for a sub 2, I'm plugging in 2 for n, so we'd have 2 over 2 plus 1, which makes 2 over 3. For my third term, a sub 3, we have 3 over 3 plus 1, which makes 3 over 4. Do you guys see a pattern? Yeah. So without even doing the work, what's going to be a sub 4 is going to end up being what? 4 over 5. A sub 5 is going to be 5 over 6. And a sub 6 is going to be 6 over 7. And again, we can write our sequence. So we have 1/2, 2/3, 3/4, 4/5, 5/6, and 6/7. Okay, questions? All right, example 2. Determine the pattern, write the next term, and write the nth term for the sequence. When they're asking for the nth term, they are asking for the formula. Sorry. Okay, so look at that. I'm going to give you, I don't know, 30 seconds. See if you can figure out the pattern and what the next term in this sequence would be. So sometimes you look at adding and subtracting. Sometimes you look to see, are they multiplying by something? Sometimes you look to see, is it some number to powers? Okay, if you notice something, talk to somebody next to you and see if they agree with you. Share what you guys think. Okay, so who thinks they have the right answer? Knows the pattern. Okay, Elton, what do you think? It's being cubed. Exactly. So do you know how you'd write your formula? Not sure? Okay, so if you notice, this is negative 1 to the third power. Because when you have a negative to a third power, it stays negative, right? And negative 8 is going to be negative 2 to the third power. This is negative 3 to the third power. This is negative 4 to the third power. So that means that the next term in the sequence would be negative 5 to the third power, which is what? Negative 125. Good. Your formula is going to be a sub n equals, and how do you think I'd write that formula? Perfect. That's it. Negative n to the third power. So this is my whole answer. They asked me to write the next term. So if this was negative 4 cubed, my next term is negative 5 cubed. And then they asked us to write the nth term, which is my formula, which is right here. So we had two separate parts to our answer. Do we have questions? Okay, moving on. Oh, are we good? Okay. All right, series and summation notation. When the terms of a sequence are added together, the resulting expression is a series. A series can be finite or infinite. Notice here a finite series. What they would end up doing is adding all those terms together. This is finite because there's an ending point. This one is infinite because it has the ... So a series is when you end up adding everything together, where a sequence is just the sequence of numbers. So sequence has the commas, series is the adding. Series, you're adding them. Sequences just have the commas. Okay? So sequence of numbers. Are we good? Okay. You can use summation notation to write a series. For example, the two series above can be written in summation notation as follows. Okay. So summation notation, anytime you see this E-type symbol, that means that you're going to add all of the terms together. Okay? This bottom number right here is your starting point. Okay? Now it says I equals 1. The reason why they wrote I is because they're using I over here for your formula. Okay? If you used N here, you would use N here. If you use X, you use X. Most often when we see summation notation, they use I for your variable. But if you wanted to use something different, you could. Okay? So what this means is that for the first term in this sequence, I'm going to plug 1 in here for my formula. Okay? This number here at the top, that is your ending point. And then the 2i right here, that is your formula. So what they did is they started with 1 and they plugged 1 in here. 2 times 1 makes 2. Then they plugged in 2. 2 times 2 is 4. Then they plugged in 3. 2 times 3 is 6. Then they plugged in 4. 2 times 4 is 8. And then they stopped. Okay, if this had gone to 5, then you would have had plus 2 times 5, which would be 10. Okay, so again, over here, this is my starting point. The difference on this one is that there is no ending point, right? And so that is why you have your infinity symbol. There is no ending point, which is why they have that infinity symbol. So this is how you know if it is an infinite series, because it has the infinity symbol, which means that the sequence would go on forever. And then, of course, that's your formula. Questions on this? No, does it all make sense? Yeah? So starting number, ending number, and when I say starting number, I mean that's the number you're plugging in to start with. That's the last number you're going to plug in, and then you have your formula. Okay, so here's 6, 7, 8, and 9. They want us just to write this information using summation notation. Okay? So let's start with 6. We're going to make our E-type symbol. My students in first period said it's basically a sideways M. Okay? However you want to think about it, that's fine. Or a sideways W, depending on which side you're writing it from. Or it looks like an E. There you go. Okay, so we're going to start with 1. Whenever you're writing them, you will usually start with 1. Okay, so we're going to write down here I equals 1. This has an ending point, but the ending point is not 100. Like, was my ending point 8 for this one? No. Okay, so we have to figure out what term number this is that I'm ending with. Okay, so we need to make our formula to figure out what term this is. So what do you notice is going on between each of these terms? They are adding by 5 to each of the terms. We talked about this when you guys were doing your CST review, but anytime it's adding by a number, it's going to be 5i for your formula, or 5n, or 5x, whatever. And then you plug in 1 for your first term. 5 times 1 is 5. Sometimes you'll have to add or subtract numbers if it doesn't get you to this. Okay, but in this case, if I plug in 1, it gets me to 5, right? If I plugged in 2, 5 times 2 makes 10. 5 times 3 makes 15, so we know it works out correctly. And then now we just have to figure out the number on top. So what would I do in order to figure out what that number for the top should be?
Figure out the last term.
Right. So there's a couple ways. Some of you are pretty smart and you're like 5 times 20 is 100. Let's say you didn't think about that, which is totally fine. I would go 5i equals 100. I would set up this as like an equation, and I'd try to figure out what I is when the answer is 100, and then I divide by 5, and I get I equals 20. So 20 is my ending point. And there's your answer. That's all you had to do, is just write that with summation notation. Questions? Okay, 7. So same thing. We're going to make summation notation. What's going to go on the bottom? I equals 1. What's going to go on the top? Infinity, because you have the dot, dot, dot. So that's pretty easy. We have our infinity symbol. And then now we just have to figure out the formula. Sometimes with fractions, it's easiest to look at them as 2 separate problems. So just look at the top right now. Figure out what's going on with the top of the fraction. It's being squared. 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on. So that means that I have I squared on the top. Now we have to figure out the bottom. Well, when I look at the bottom by itself, I am having a hard time with that. But if I look at the fraction together on this one, do you guys notice something?
It's the number of
Oh yeah, they're one number apart.
These are 1 number apart, right? Whatever this number, they're adding 1 to it. Whatever this number is, they've added 1 and so on. So what would be that formula for the bottom then?
I squared plus 1.
I squared plus 1 is correct. Good. And that's it. You're done. Okay, so moving on to 8. I hear some of you already talking about it. Do you guys think you can try this one on your own? Okay, what should always go on the bottom? I equals 1. If they don't tell you, that's what they said way back when. If they don't tell you, it starts with 1. Okay, on the top, what's going to go on top? Infinity. And how do we know? Very good. Okay, now I heard somebody say what's happening between each of the terms. What is it? No. They're multiplying by 6. Somebody said they're 6ing. It's multiplying by 6, each of them. Instead of squaring, they're multiplying by 6. I don't know. Okay, so remember what we talked about is, oh, actually we didn't talk very much about multiplying. Okay, but let's think about this. In order to get 6, if you're multiplying by 6, 6 to the first power is 6. 6 to the second power is 36. What's 6 to the third power? So, how will we write our formula? 6 to the I power. Because whatever the term is, it's being raised to that power. This one, because this one's multiplying and this one's adding, that's why they're different. So when you're multiplying, you're going to have like an exponent, where when you're adding, it's going to just be multiplying. We'll try that. If you did 1 to the 6th power, what does 1 to the 6th power make? Okay, what about 9? Are you guys trying this one on your own? Try it on your own and then check with who you're sitting next to see if you guys agree. Okay, so what do you guys think? First of all, we know this is an infinity because it has a 12 as an end, right? So that means there's an ending point. We just have to figure out what the ending point is. So what did you notice was happening between each of these terms? Adding by 1. Remember how this one was adding by 5 and we did 5i? So if this one's adding by 1, we're going to do 1i or just I. Okay? Now, when I plug in 1 here, I get 1. And what would I need to do to 1 to make it a 5? Add 4. And then you could double check it. If I go to my third term, 3 plus 4 makes 7. Okay? Now, to figure out the 12th term, and again, some of you are pretty smart, and you know that 8 plus 4 makes 12. And so we know this number is 8. But if you didn't think about that in your head, and sometimes it just doesn't register, write out the formula. I plus 4 equals 12. In order to solve for what I is, you would subtract 4 to both sides, and you get I equals 8. And this is my answer. What? Like explaining the formula? Okay, do you understand how each of them are going up by 1? Okay, so remember how here each of them were adding by 5? We did 5i. Yes? So if each of them are adding by 1, you're going to do 1i, or in this case, just I. Okay? Then you have to figure out what do I need to do to this in order to get it to my first term. Back on this one, if I plugged in 1, 5 times 1 made 5, which was my first term, so I didn't have to do anything. But on this one, when I plug in 1, I get 1. So what would I need to do to this to make it 5? Add 4. And then I always double check it with a different term number. So I'm going to my third term. If I plugged in 3 here, 3 plus 4 does make 7. So my formula works. And then we had to solve this for my ending number to find out that the last term is actually 8. So I just took my formula, I plus 4 equals 12, and solved for I. Okay? Oops, sorry. Okay, any other questions on these problems? All right, this last part asks you to find the sum of the series. Okay, notice the starting point and the ending point. So on this first one, I'm going to have a sub 1 all the way up to a sub 5. So sometimes I like write them out so I remember to do all of the terms that I need. Okay, so I wrote out 1 to 5. And I'm plugging in each of these numbers for I to find out what it equals. So we have 8 times 1 is 8. Next one I'm going to plug in 2. 8 times 2 is 16. 8 times 3 is 8 times 4 is, and then 8 times 5 is 40. And summation notation means you're summing them up together. So once I have all the terms that they wanted, I need to take these terms and add them up. And you add all those up together and it equals 120 is correct. Are we okay? All right, what do you notice about 11? What does it start with? 3. So be careful of that. So we are going to have, and they use K this time, but you can use whatever you want. But I'm just going to still put a sub 3, a sub 4, a sub 5, a sub 6, and a sub 7. You could write anything that you want. So they're starting with 3, and they went to the 7th term. Okay, you can write all these out if you want to, but I think we can do these in our heads, I'm hoping. So 3 squared is what? 9, and 9 minus 1 is 8. 4 squared is, and 16 minus 1 is 15. 5 squared, 25 minus 1 is 24. 6 squared is 36, minus 1 is 35, and 7 squared is 49, minus 1 is 48. Okay, so then we take all these numbers and we add them up, and it equals 130. Because again, anytime we have this E symbol, it means summation notation, which means they want you to add them all up. Okay, last one. It says I equals 1, it's going to 34, and do you see a variable over here? No. So what that means is the first term is 1, the second term is 1, the third term is 1, the fourth is 1, all the way up to my 34th term being 1. So if you were to add up 1 34 times, what is your answer going to be? You guys are super smart. Any questions?